Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 9th, 2025, about 2 days ago, and this paper centers on competitive programming code generation with reinforcement learning and verifiable rewards. It shows a two-stage recipe that lifts performance sharply, including a 58% relative improvement on Codeforce's weekly over-supervised fine-tuning and about 16 to 17% gains on LiveCode benchmarks, while matching much larger systems. The paper is titled Drive Data Curation Best Practices for Reinforcement Learning with Verifiable Reward in Competitive Code Generation. And as we will see, the implications for training data and curricula are quite significant. Figure 1 shows that the two-stage training yields the highest accuracy across LiveCode Bench, LeetCode Weekly, and Codeforce's Online Judge. An online judge is an automated system that compiles and runs code against hidden tests, so it provides a clean, verifiable reward signal. The Drive Reinforcement Learning model surpasses the Drive Supervised model on every suite, which suggests the entropy expansion and hard-focus curriculum improve generalization. On Codeforce's Weekly, the relative gain over supervised fine-tuning reaches about 58%. While Figure 2 shows the end-to-end training pipeline that produced those gains. The top band outlines supervised fine-tuning, where mixed coding and reasoning data get difficulty labels and hard problems are duplicated to emphasize challenging skills. The bottom band depicts two-stage reinforcement learning with verifiable rewards, which means the model executes code in a sandbox and receives pass or fail signals from test cases. Entropy expansion uses a shorter context to push diverse outputs across about 9,000 prompts, reducing repetition and truncation. The hard-focus curriculum then concentrates large rollout budgets on the hardest LiveCode V6 tasks, so pass rates converge steadily. Figure 3 shows that a 24K context raises entropy over training. In contrast, a 32K context steadily lowers it. Entropy here means the diversity of the model's outputs, which signals broader exploration rather than collapsing to one solution style. This widening diversity reduces repetitive structures and truncation, so the first reinforcement learning stage can better prepare the model for the hard-focus curriculum that follows. So, Figure 3 highlighted entropy effects. Table 1 compares supervised fine-tuning with strong baselines on 2 weekly online judges. On LeetCode Weekly, all methods reach the same pass at 10, which means up to 10 attempts are allowed and success counts if anyone passes the tests. Single-shot accuracy differs, with the seed model leading by a clear margin. On Codeforce's, the supervised fine-tuning model trails both competitors, so gaps widen on the harder set. This pattern motivates entropy expansion in a hard-focus curriculum, because similar results on easier tasks can mask weaknesses that tougher problems expose. So Table 2 reports pass at 1 accuracy across multiple code benchmarks, which means single-shot success without retries. The result shows the reinforcement learning model ahead of the supervised model on every suite. Focus on the reinforcement learning row compared with the supervised fine-tuning row, which highlights steady gains. The bottom band lists relative improvements, with a peak of 58% on Codeforce's. Stage 1 alone provides smaller boosts, so the full two-stage recipe matters. Alright, Table 4 probes which reinforcement learning choices matter using an ablation, which means toggling components to isolate their impact. Training on the full LiveCode V6 dataset hurts generalization, slashing LeetCode Weekly to about 0.30. Skipping stage 1 performs better than those broad mixes because the hard focus signal stays clean. The two-stage recipe wins, and adding even more hard samples in stage 2 nudges scores slightly higher on every suite. On Codeforce's, the final scores reach about 0.18. Alright, 2 takeaways stand out. Data curation and curriculum design matter as much as the reinforcement learning algorithm, and a two-stage recipe that expands entropy then hard focuses with large rollouts delivers big gains, including roughly 58% on Codeforce's. The broader implication is clear. Verifiable rewards plus thoughtful curricula can close the gap with much larger systems. Thanks for listening. I am Alex, signing off.